As Anna mentioned, I'm going to be talking about disease updates. So, kind of talking about what we saw in 2024, and then also looking forward into the future is what we could potentially prepare for going forward into next season and beyond. Okay. So, many of us can still remember the end of the season, very, very dry, and it's very easy to forget about the beginning of the season. And imagining this again was across much of the eastern and the central portion of the state in 2024, with a lot of standing water, delaying a lot of planting. There's a lot of areas in which we can see that these plants got drowned out, leading to some dead spots in fields and other issues going forward. Now, from a pathology perspective, okay, this moisture is going to lead to disease development. Most of our, if not all, of our important soybean diseases are driven by moisture. And so, especially early in the season, some of them that we dealt with are what we call our seedling diseases. And our seedling diseases, there are four of them. We kind of group them into what we call our true fungi, which are called the Fusarium and Rhizoctonias. And then we also have two what we call our oomycetes or water molds, and those are our Pythium and Phytophthora. Okay, and those are very distinct differences between those two groups of seedling diseases. Now, this is an image of one of our research plots from this past year. And you can see where that stake is. That's that first row of that new plot or that new treatment. And we can see this very distinct difference. And this is very early in the season. Okay, this is about 10 days after planting that these, and you can see still how wet that soil surface is. But the plants on the left-hand side, they did not have a seed treatment. And you can see this brown lesion coming up through that cotyledon, okay, starting to fully girdle that. And we see that that individual plant is dying off. And when if you picked it up, that seedling, it didn't stand up straight. It just kind of flopped over. Okay. That individual plant is not going to make it. But if we look on the other row, okay, where we did use a seed treatment, these seedlings emerged and they were healthy and they did not have issues with germination. They did not see stand loss due to these seedling diseases early in the year because of a seed treatment. Okay, now this is really important in years that it's wet. So just a couple of early season considerations when thinking about seed treatments. And these are not pros and cons, these are just things to consider. Okay. So these seed treatments, they are only important for early season protection, typically 2 to maybe 3 weeks of protection. It's essentially getting that seed from in the ground and getting it to germinate. Once it's out of that 2-week period, we don't see these chemicals having any more efficacy on these diseases. Another important point with seed treatments is that it does protect the root system. And it's not just about preventing infection today, it's preventing that root system from being compromised. And then later in the season, if we experience a drought, then that root system is not able to, or it's not fully developed. So those plants are not going to be resilient against drought conditions. Very similar to what we saw in 2024 again. The other really important thing to consider about seed treatments, different than some of our foliar fungicide treatments, is that we are using very, very low levels of these pesticides. Okay, these are very targeted only to that seed, and a certain range just outside of that seed is being protected. We're not applying these chemicals broadly across the field. And that's important because we are going to be at a reduced risk or low risk of developing resistance to these fungicides. And that's important for long-term viability of this as a tool for management of these diseases. Now, the other consideration here, and the last one, is that these seed treatments may not always be beneficial, especially in years in which we have low moisture. So if we have a very dry spring, okay, these may not pay for themselves. And many of these seed treatments are being put on as packages. Oftentimes they're coming with the varieties, but sometimes we can do what's called a topper upper. Okay, we can add additional seed treatments on. And many times these decisions are made many months before planting, and we're not able to make these decisions on the fly. Okay. So again, just considerations. So we're going to walk through just a little bit of data here from some seed treatment evaluation trials that one of my grad students, Vanessa Laux, is running a part of her master's program. Now, this is work funded through the Soybean Council here in the state, and so we're very thankful for their support. And we're looking at 9 different seed treatment packages. Okay, these include both fungicides, our products that are targeting the oomycetes or the water molds, and we're also having some insecticides in there as well. Now, the first one is a non-treated or a naked seed that's going into the ground, just as our control to compare against, just like what we saw in that image before. Then we have Allegiance, which is targeting towards these oomycetes, Rillenia, which is good against Fusarium and Rhizoctonias, or has activity against those two. And then combining those Allegiance and Rillenia together, getting the full spectrum of both the fungi and the water molds together. We've also got Vibrance Trio, which is a common seed treatment package, Cruiser Max APX, which is relatively new with this new active ingredient called picarbutyrazox. Okay, and that one is coming out of Syngenta, in which that again that PCBX product does have a new activity against these water molds as well. Lumicina and Lumiderm. Okay, the oxythiopyprolin is also another good water mold product with an insecticide. Allegiance and Aceleron, again, kind of full spectrum looking at fungi and the water molds. And then the last two are combinations of Vibrance Trio with Cruiser 5FS or thiamethoxam insecticide, and then same thing with the Allegiance and Aceleron combined with Cruiser 5FS. Okay. Now, from these trials, we did run these. We run these at a couple locations, but I'm only going to present the eastern side, in which we saw very high levels of moisture. So these are just from the 2024 growing season. We're going to be performing these trials for a few years into the future as well. So these are combined across locations at Fargo and at Oaks Irrigation Research Site. Now, these trials were planted 140,000 seeds per acre, and that'll be important for this particular slide. Because what we're looking at is the final soybean stand, and this is estimated at a plants per acre basis. Okay. Now, across the board, you can see the non-treated on the left-hand side here, and we see the lowest levels of plants present within this particular treatment. Okay. And if you're not familiar, I think Joe Eichley walked through this earlier, but if you're not familiar, the letters here, if a treatment shares a letter, then it is statistically similar. And if it does not share a letter, then they statistically differ. Okay. So our non-treated is here, does have the lowest, but is statistically similar to both the Rillenia and the Allegiance treatments, okay, which is our single mode of action products. But as we look over to the right, there are many of these products that have high final stand counts, but we still see consistent stand loss or reduced germination across the board. Again, thinking about this, we did see, or we planted these at 140,000 seeds per acre. The non-treated, we're getting 65,000, and the best product here that we found is only getting 88,000. So that difference is still important. We're still saving about 22,000 plants per acre by using a correct seed treatment. Now, what's really important is the yield. Ultimately, that's what majority of the farmers are going to be looking at here. And so this is the exact same type of figure, but again, the non-treated on the left-hand side over here yielded an average of 36.3 bushels per acre. The best product on the right, the highest performing, was 44.4 bushels per acre. Okay, so that right there is an 8 bushel advantage just because of the individual seed treatment that was used. Now, one of the interesting things that you're seeing here is that, again, that highest performing product was our Vibrance Trio in addition to the Cruiser 5FS. But if you look over here, the Vibrance Trio alone, interestingly, had the lowest yield, again, about 36 bushels per acre. Now, we're still trying to understand biologically what is going on, but the addition of this Cruiser 5FS, the insecticide thiamethoxam, is leading to this benefit for this particular product, the seed treatment package here. Okay, so there are some really strange interactions, but we're very thankful to have have good data coming out of these particular trials to see differences between these seed treatments. Now, we took this a little bit one step further into what's called a partial profit analysis. And this is not a full economic analysis, but this is just accounting for the cost of the seed treatment alone. And so what we did is we took the yields from each of these treatments, and then we multiplied that by the grain sale price. And so at the time that we did this, it was estimated at $10 per bushel. And then we subtracted the cost of the seed treatment from that to get this analysis. And so again, we're not talking about this as the pure profit. This is a partial profit, only considering the cost of the seed treatment. And so when looking at the non-treated, okay, we had about $363 of profit, partial profit here per acre. And then again, this Vibrance Trio plus the Cruiser 5FS had about $437. Okay. And this led to a whopping $74 advantage per acre because of the correct seed treatment in this particular case. Okay. Now, there are many different products out there, many different combinations that we can do. Again, topper-uppers are also available if the package that came with the seed that you have purchased is available to increase your protection. Again, making sure that we have that full level of protection across the board of all the different pests and pathogens that we may see out in the field. So the next thing that we're going to talk about here is a new disease that is in the state, okay? Now, many of you may have seen symptoms like this. There's a couple of other diseases as well as some fungicide issues that can occur and cause similar symptomology. But this is called sudden death syndrome. And this is caused by a fungal organism in the soil called Fusarium virguliforme. Now, I mentioned earlier that there's other seedling diseases called fusariums as well, but this Fusarium virguliforme is very distinct. It is not often considered in the same grouping as the seedling diseases. And so because of that, we considered a just completely different disease here. Now, sudden death syndrome is much more of an issue in the I states where it has been established for many years, but it was first identified in North Dakota in 2018 in Richland County. Very isolated case, but it was confirmed. 2 years later, and I don't know how this happened, but 2 years later up in Cavalier County, SDS was again confirmed. And after 2020, it went radio silent. No more SDS. We didn't find it anywhere in the state. It wasn't here. We couldn't even find it in Richland or Cavalier County at all. But then in 2024, because of all the excessive moisture that we saw early in the season and throughout the early to the middle part of the season, we saw SDS again develop. In Richland County in particular, we saw almost every field I stepped into, I found SDS at some level. It was symptomatic. And then again, we found it in Cass County, as you can see in the map. And then in Dickey County, around the Oaks area, we found SDS at fairly high level within an isolated pocket. But again, the pathogen appears to be spreading outward from this initial kind of establishment in Richland County, whether that is through soil or seed varieties or it is wind blown. Okay, this pathogen is moving. Now, since this is a newer disease, I want to make sure to kind of go over the biology of this particular fungus, as this is something that's a little distinct and is a little bit slower to develop than some of our other fungal pathogens. So SDS does persist in the soil. It lives in the soil on crop residue. And one of the important parts is that it doesn't just survive on soybean residue, but it also survives very well on corn residue. It's not a pathogen of corn. It doesn't kill corn, but it really likes to live on that corn residue. It's what we call a saprotroph, and it eats away at dead plant material. Now, what happens early in the season, okay, if we have heavy moisture and if we have some abiotic stress, whether that's compaction due to, again, wet soils and kind of pushing seed in the ground when we probably shouldn't be, okay, these plants are going to be stressed, and that's when the infection from this Fusarium virguliforme is going to occur. Now, this fungus, it doesn't kill the plant, okay, but the fungus will establish itself within that root tissue. And once it's established in that root tissue, it kind of just goes dormant. It doesn't kill the plant. It doesn't really do anything. It just kind of hangs out, okay? It's a tenant that's not paying rent. Then later in the season, okay, typically around the later reproductive stages, as early as R4, but typically R5 to R6, and it's usually right after a heavy rainfall event, this pathogen will sort of wake up. Okay. And when it wakes up, it produces a toxin, and this toxin moves upward throughout the plant, moving to the leaves. Now, once this toxin reaches the leaves, the soybean leaves themselves will get that interveinal chlorosis again. So those really yellow leaf tissue with dark green veins. Okay. Now, when this establishes itself at high enough of levels, these leaflets will start to drop to the ground prematurely. And one of the key diagnostics here is that the petioles will remain attached to that stem. So it will be a bunch of naked stems with these little pointy petioles sticking out all over the place. Now, this is a field here from this past season in 24, and you can see the yellowing that's kind of occurring across this field. Now, 7 days before this picture was taken, this field was a deep green, was perfectly healthy, didn't show any signs or symptoms of any disease appearing. And just like the name suggests, it was a very sudden death. Okay. So you can start to see, even here in the forefront of this picture, you can see leaf matter on the ground. And these plants are still at R6. They should not be dropping leaves yet. And so because of that leaf drop, these plants are going to be reduced photosynthetic activity, leading to reduced yield. And you can see here again in this picture some of these petioles without the leaflets attached. And you can see this yellowing and this kind of browning discoloration within the leaf, with the veins still being green. Okay. Now, one of the other really important signs, and I have to add caution to this because this is not always present with SDS, but it is frequently, but do not use this as a key diagnostic, okay, is this blue fungal growth that appears on the taproot, okay? It can appear on lateral roots as well. You can see it appearing over here, but it is a very distinctive dark blue color. Now, SDS is one of the only diseases that will have this. So if you see this blue growth, then it's most likely SDS. But if you think it's SDS and you pull up a root and there's no blue growth, it could still be SDS. Okay. Another very key diagnostic here is the cortex tissue of that stem. It is going to look sort of bruised. So what we recommend is you pull plants up that you think are symptomatic, and you take a sharp knife and you just start to slowly shave away on the outside, brown the soil line on that lower stem. And if you start to see bruising appearing, then that's most likely going to be SDS, the Fusarium virguliforme pathogen causing that infection. Now, I mentioned earlier that there's some other diseases that can cause similar symptomology, this interveinal chlorosis and plant death. But one of the differences here is when you split that stem. Okay, you can see this is SDS, and SDS has that brown cortex, but that white pith, the very center of that soybean stem, is very white. Okay, that is not rotten. That looks very healthy still. Now, on the inverse, if we were looking at brown stem rot, okay, it would be exactly the opposite. That center pith would be rotten out while the cortex is still very white. Okay, so by taking these stems, by splitting them, we can see these very clearly that this is most likely a symptomatic SDS infected plant. Now, SDS also has a very strong association with soybean cyst or SCN. And this is one of the main considerations or main concerns that I have about SDS developing here, is because especially in the eastern side of the state or in the Red River Valley, we have very high levels of SCN, some of the highest in the country, actually, for soybean production regions. Now, this is work done out of Michigan State, looking at this association between SCN and SDS. And so in these figures, this FV here, that's the Fusarium virguliforme. So looking at the levels of this SDS pathogen in the soil, as well as the SCN concentrations at planting. And so we can see this particular pocket up here in this figure, this is the western side of this particular field. Then at the R5 growth stage, they came back and they rated for the SDS development, and we can see it's in that exact same pocket. And then at planting through the harvest maps or yield maps here, we can see the decrease of yield in the areas where SDS and SCN were highly associated, leading to the conclusion that there's this very strong association. Now, again, to demonstrate that again, in 2015, another trial was performed, same exact concept, looking at that SCN concentrations at planting, and we can see these high pockets right down here, these very circular dark green areas, high levels of SCN. Then when we take that to SDS, we see almost the exact same areas having higher level of SDS comparatively to the areas just outside of that. And same thing with yield. We can see this decreased yield right in those areas where SCN and SDS are both present at the exact same time. And we don't see that SDS shifting outside of those heavily infested SCN areas. Okay. So for management of SDS, the important thing here is early season protection using seed treatments. And we do have a few that are available, but again, many that have activity against the other fusariums do not have activity against the SDS pathogen. The other tools that we have at our disposal are genetic resistance. And genetic resistance can be deployed in a couple of different ways or understood in different ways. So first, we can prevent that initial infection. We have resistance again, whether or not that fungus can infect into that root tissue. Okay. The second way could be the root rot, preventing that establishment. Once it is infected, making sure that that pathogen does not grow within that root tissue. And then the last and probably the most common form of resistance that we have for SDS is the susceptibility to the toxin. And so even if that pathogen is present in that root tissue, if that sends that toxin up and if that plant does not respond to the toxin, then we don't see the leaf drop. We don't see that reduced photosynthetic activity of that plant, leading to yield losses. Now, the major concern here is that we, as farmers in North Dakota, do not have much resistance available, okay, because this has not been an issue that we've dealt with. And so currently across the 0 and the 00 maturity groups, we don't have many options currently, but hopefully the breeders are working on this going forward. So the last thing I want to point here is to the Crop Protection Network. Every year, the extension specialists across the U.S. and across the Midwest come together, and we put all of our fungicide trial data together into these tables called our fungicide efficacy for control of soybean seedling diseases. Now, on the left-hand side here, we have our active ingredients, and then we have each of the diseases that we're looking at. And those will give you ratings for whether or not those products have, or those actives have good activity or not against each particular disease. So thinking about these two oomycetes or water molds, Pythium, Phytophthora, okay, we'll see these 4 products, ethoboxam, mefenoxam, metalaxyl, and oxythiopyprilin. Now these products, they have excellent, for most cases, for these oomycetes, but they do not have recommended application for the fungi because these are products specifically designed for control of the water molds and not fungi. You can kind of see the similar trend when looking at the fungi relative to the oomycetes. Okay, so this is a really great resource that I would definitely push anyone to if you have questions for seedling diseases or seed treatment considerations as to what you think would be a good option for the coming season. So with that, thank you all. Thank you, Anna and Jeff and Linda and everyone for organizing and getting it right, as well as the Soybean Council for all the support.